Hello students coming to Java programming academic year 2021 second BTech semester 2 R90 JNTK Kakinada regulations. And we know that unit 3 consists of two chapters. Chapter 1 arrays in Java and this chapter 1 arrays uh, composed in 5 videos, and currently we are in video 4. And these are the topics going to be covered in Unit 3 of Chapter 1 Arrays. We have the first one, searching for values in arrays. Search is another operation applying on the values that are stored in an array. And an array we considered in Java as a class, and how this class can be used to get some more operations that are admissible on the possibility of storing values in an array, and we will see that topic in this video. Coming to the first one, searching for values in arrays. And these arrays are also useful in the process and operation of searching for a desired value in a set or a group of values. That is nothing but now coming to here, searching of operation nothing but searching is the process of finding one desired element of given group or set of elements, nothing but array. This search an array for value is often needed in many type of applications as it is. Let us consider the example of searching for your name among the reserved seats in retail reservation chart. And we know generally do this process of searching when we are going using train transportation, and when we have a reservation seat, when we go to the coach, there is some list of reservation seats available, and we go usually for searching for the name in the chart list. And we are searching for the entry, right? And also in the case of air travel reservation chart, this is also the doing application, one of the real-time application for this searching of an entry into a group of given list of elements. And searching for a book in a library, as there are some racks of books are available arranging in a rack by rack, and we are searching for a particular book is also one of the application we usually use in our real time and in our daily life. And there are many type of applications like this where we use logical point of view or coming to the soft component point of view in our computer system. And generally we have some database of some entries of books, and when we are going for search a book of in this database search, and searching is one of the application in that area, right? And there are two methods available for this searching. You already familiar with this. Two methods, linear search and binary search. For linear search is for unsorted order element or unordered elements. This searching of application for unordered elements, and whereas binary search is for sorted arrays. So unordered or unsorted elements are taken into arrays, and on this array applying linear search is one way, and whereas some sorted array elements are taking and applying binary search algorithm to find the desired element of the given group of elements in a form arrays. Coming to the first one, linear search. And linear search is also called as sequential search. And it is a very simple method for searching an array for a particular element or a desired element. Okay. Okay. Now here it works by comparing the value to be searched with every element of the array, every element with the every element one by one. every element one by one in sequence until a match is found or at the end of the array. And during this process, if you may found any element, then the search operation is successful and your desired element is found. If you not found any element by this process till the end of the array, that it mean of the search operation is unsuccessful and the desired element is not found in the given array elements. And this linear search is mostly used to search an unsorted list of elements. And this methodology, linear search methodology, is generally applied in the process where it applies on the unordered list of elements. So here array in which data elements are not sorted. Unsorted means not in a sorted order, not in a sorted order. Coming to the linear search example, consider I have an array with size 5 elements can hold to store, considering the array in type as an integer. And this array can hold an integer of 5 elements. The size of an array is 5 here. And these are the consecutive memory locations given in the array, in the memory for reserved for this array to hold 5 integer values. And coming to here, consider this array is composed of these 5 different integer elements. And that too, if you observe here, the elements are in unordered, unsorted order, right? And I'm going to find the search key element, that is 38. I'm going to search this element 38 here. And the process of linear search is searching every element one by one from first index element to last index element until the key forms or it reaches the end of the array element. Coming to the process, here it first compares this 38 element with element 15 and it compares the first one. It compares with this first index element of the key search. If it is matched, the search operation is successful. If it is not matched, here the search operation is unsuccessful. Got it? Then what it do? It go for searching for another index. Next index is one element. So here it goes to 87, second index position, and it compare both this 38 and 87, and both are not matched. So match not found. Then search is unsuccessful. So search is unsuccessful. Increment the index to search next element in the array position. Then compare this 38 with 25. Here also the comparison failed and search operation is unsuccessful. Then it increments the next position index and that it is 38, 38. Here the process comparison is successful. So the search operation is successful. So the process of linear search is terminated at this position and it simply gives the outcome of this operation as the search element is found at the index 3. The search element key 38 is found at index 3 or position as position in the array at this position. What is the position here? First position, second position, third position and fourth position of an array. But as point of view index, it starts from 0, then we give index 3 or position 4. Got it? The key found at location 4 or that is index plus 1. That is linear search. Coming to the binary search process here. Here consider an array A that declared and initialized as with these elements. So when we are going to apply the binary search on a given array elements, and this array, for applying this binary search, this array should be sorted first. This array should be sorted first. So if you observe here, all these elements are in sorted order. All these elements are in sorted order. Got it? And we are going to search an element value 9, element 9. Is this 9 element exist in the given array of elements or not? By using binary search algorithm. Right? Coming to the algorithmic process of this binary search. So initially we take the beginning variable index as 0, ending index as a 10 here, this is position. And mid value we calculate based on lower index of an array, higher index of an array. Why? Because here total 11 elements there, 0 index, 1 index, 2 index, 3 index, and up to 10 index. So range of index of this given array is 0 to 10. That it means total 11 elements there in this array. So that's why low index of the array is 0, high index is 10 by 2. So that is as an integer, it takes this as 5. So now value 9, I'm going to search for this element, is that exist in the array or not. So I calculated this mid value and I pass this mid value as an index where I'm going to search for an element 9. And 9 compared with A of 5 element. A of 5 in the array is 5. Is this 9 and 5 matched? No. So A of 5 is less than to compare this search element value. Therefore, we now search for the value in the second half of the array. So when we are comparing the 9 element with this 5, so 9 is not matched, and we go for another comparison, and where to compare the second comparison for this element 9. So when compared with this mid position element, that it is 5, and 5 compared with 9 is smaller, so 9 should always be in this right part of the second half of the array, in this part. We should search for this 9 element in this part, not in the left side of this element mid value. Right? As it sorted order of this elements, 9 should be greater than to 5. So it available in the right sub array of the mid position. So to make that search element, we change this beginning value to mid plus 1. Initially we have taken beginning as 0, but here now going to search in the second half array. So we take beginning equal to mid plus 1, that is the value 6, and again keeps the same. And we take the same process when 9 is comparative mid value is smaller, we go for second part of the array position. So here mid calculation again, 6 plus 10, 2, and 16, 2. So that is index 8. And we go to this index 8, and that is element 8, and compare this element and this element. Usually this doesn't match the answer. So 8 is less than value. Now we search for the element in the second half of the array from that position. So here again mid equal to beginning equal to mid plus 1, that is 9, end is 9. 9 plus 9 plus again value. So 9 compared with this A of mid, that is 9. So both are same. The search operation is successful and the element found. And you may get some little bit confusion here. I will go for a simple example to better understanding this binary search process. So consider this is an array. As I told you, the size of this array is 5, and this array type integer and integer. So it can hold 5 integer type values into an array, right? Okay, coming to this one. So first of all, take the element of an array in a sorted order. So here all the given elements are in sorted order, and these are the indexes of those positions, right? First take the two variables beginning and ending. So first we go for search value. that it is 43. Is this 43 element exist in this array or not? Okay, first take the beginning value as 0, and that is that this is the index here. This is the index, and end equal to 5, and that is the index at this position. And find the mid value. Mid equal to beginning plus ending by 2 equal to 0 plus 5 by 2. That is index 2. So this is the mid position. And compare this 43 with this mid value. So compare this 43 with this mid value 12. And when we compare this one, search is unsuccessful. 43 is not matched or not similar to element 12. So what will happen? Compare this 43 and 12. So 43 is greater than. So bring this beginning to this mid position, mid plus 1 position here, and again apply the same process. So that is. So search1 is 43. What is beginning here? Mid plus 1. In the previous slide, what is the mid value? We got 2. 2 plus 1 is 3. So the beginning will keep to this position index of the array, and end equal to 5 at the same position. And apply the mid value here. So mid equal to beginning. So we got mid value as 4. That is this one. And compare this 43 with this mid value, this one. And here it is compare similar, and search is successful. The element is found. The element is here found. The element 43 is found in the given array elements. So this is the process of applying binary search on an array of elements for finding the search value. And the second topic in this video is class arrays. And we know that array is a class in Java. And this array class has many type of functions and methods built in the array class. And we can just include those packages, and this class array defines in the package called java.util. Java.util. So in this package, this class array is available, and inside this class array, there are many type of functions are defined, and we can make those array methods into use and see. Let me explain that one. This class array with static methods. This class array with static methods for general purposes that are carried out on arrays, generally for array group of elements, and we apply these methods on the arrays, such as sorting. Sorting is a method is already defined in the array class, and this sorting of an array for full length of array and or a part of an array, you can apply this sorting method or application to arrange the elements of array elements into sorting order. And we can apply binary search of an array for the full array or the part of array. You can apply this, and as we required in the search process, and you can apply the search operation for full array or maybe some part of an array. For comparing also, comparing two arrays, so it is also available, and they are not equal for filling the part of the full array with the elements having specified value, and copying an array to another array. That is also some, and these are the different types of methods that are already defined in the class array, and we can get those by extending a special class called object class, and we'll see this object class concept in the second chapter of this unit 3 inheritance, and clearly we will go through this object class. And coming to the sort method of an array class is based on quicksort technique. And this technique, and when we are applying sort method of the array class, and that sort method is composed of the best sorting algorithm is quicksort. The methods are applicable to all primitive types as well as class objects. And we can apply these array class methods and applicable to all primitive types like integer array, like that. And as well as this class objects also are possible to make, apply and applicable of these methods too. And this class array are declared as this one using access specifier public using keyword class. You can define this arrays like this: a capital A R R A Y S arrays, and extends nothing but is an inheritance concept, and we are extending the properties of this object class. So now it is a superclass, and this array class will become as a subclass of this one, and we discuss this one in the next chapter clearly. And coming to these are the methods of class array, and these are the different methods of class array. And these methods you can invoke in your programs to make, apply these operations on the array or a set of an array directly without writing code. Once again, you can simply call, by extending this object class by this array class, you can make call of these methods for arranging the given input, given array elements into sort. And we told you that quicksort algorithm. And you can apply binary search. You can check for equal of both arrays or not. You can fill, you can copy of, as we can array represent as a list to string, you can do deep to string and hash code point of view. And all these methods are already available in this class array. And we make use of these in our programs and by invoking them. And this is the website link for you to understand about more functions and how their syntax is given for this. I will show you now. Okay, now coming to this website. So here it is that creating this array class Java utils arrays. So by importing this one, by importing java.util.arrays, and we can make use of all the methods defined in the array class. And if you this see in the previous slide, we know this one public class arrays extends object. Object is a class now, and this class contains various methods for manipulating arrays such as sorting and searching. It also contains a static factory that allows array to be viewed as a list of elements. And all these methods are uh, starting from this JDK 1.2. And these are the different set of methods defined here. Static list, as list object, we are passing an array and it returns a fixed size list backed by the special array. And like this, if you observe this static binary search, and here it is for different types of primitive types, byte value and byte value here. And here it is character, and this binary search for double values and float and integer, long, object of the classes, and like that. So there are different short keys and all these static int binary search method, and also told you that equals to equals method, and we can compare boolean arrays a and a2 both are equal or not. We can apply this method to find the equals in both the arrays. For byte arrays, character array, double array, float array, int array, long array, like that, and equals of objects of two different objects of array objects, and short values. And fill function. This assigns a specified boolean value to each element of specified array of booleans. And here are booleans, and with this something indexes, byte values, fill function for character, and from index to int index, to index and from index. From this position to that position, you can fill the character values into the array of elements, like that, double float, like all these are fill values. You can use this syntax in your program by passing array as a method, array as a parameter argument to these methods, and by simply calling and invoking their methods by using that array class, right? These are the different cases, and can we see one example of here? So we can make this type of method, sort method, by passing a as an parameter to the sort method, and we can get an array to be sorted, the array to be sorted, like that. Many type of methods are defined in binary search, right? And all these things are designed as a methods in the class array, and we will discuss that object class more clear in the next chapter. Coming to these are the references, and thank you.